Okay, so we're going to do, what we're trying to do here is we're really trying to use probability to help us analyze decisions a little bit further, okay? So now here's what we're going to do. Take a little story. We're going to say that it's a 4th of July, I don't know, a parade or something that's going to happen, right? Now, nobody wants it to rain on your parade, right? But it's the 4th of July parade on my mind because we just passed the 4th of July recently. So here we go. It's the 4th of July parade. Now, the mayor of our town says, hey, wait a minute. You know, the committee gets together, the town council gets together and says, should we have the parade this year? And they know, yeah, because there's only a 3% chance of rain in July. Given any given day in July, there's just a 3% chance of rain. But then, a couple days before, the forecast comes out, and guess what it does? It calls for rain. So we have this idea that it might rain. So the mayor gets word, and he says, oh boy, if it's calling for rain, let's just cancel the parade. With all the costs and expense and everything else, we can't afford to go to all that, trouble, and, and maybe it's going to rain. Well, somebody says, look, most of this is all volunteer. It's not going to cost the city any money. We'll get donations. We really want to have a parade. And he goes, well, what's the point? Because it's supposed to rain. So they say, well, there's no guarantee of rain. And he says, okay. So they go back and they look it up. And they say, they took every day that it rained. And they looked and said, okay, we know that it rained on these days over the last 10 years or so. And on the days when it rained, they checked the weather forecast, and guess what they found out? They found out that if it rains, okay, so if it rains, that there is a 90% accuracy in the forecast. Turns out that it had called for rain 90% of the time. And when it didn't rain, if it didn't rain, so it is not raining, then it is true that the weather was calling 5% of the time it called for rain. So it was, in other words, it was wrong. So with this information in hand, the mayor says, see, look at this. When it rains, there's a 90% chance that, that it was called for rain. And, only a 5% chance they called for rain when it didn't rain. So clearly, we can conclude that, it's probably going to rain here. So it is more likely to rain here than not, right? So I want you to just stop for a minute and thinking about this information here without doing any calculations. Is the mayor wrong? Is the mayor, what do you think the probability is for rain given that the forecast is calling for rain? So let's go over what let's use some probability terms here. We'll first of all, we'll define event A as rain. So when it's raining, the probability of A, so the probability that it rains, we know that to be 3%. All right, and the probability that it's not going to rain is the complement. Remember, the complement, I told you this would come back in handy again. Now, the complement is all the days that it doesn't rain. So what's the probability that it is not going to rain? Yeah, you got it. It's 97%. All right, let's talk about event B. What is event B? Well, we'll call event B the forecast for rain. Okay? So the forecast for rain. So what are these things here? Well, this is just our probability of A right here. This one right here is just the probability of A. But what is this one? It says, if it rains, then the probability that there was a forecast, that means it was 90% of the time, given that it rains. So this is actually the probability that there was a forecast for rain 90% of the time is the answer. So it's telling us 90% of the time there was a forecast for rain when it rained. Remember, first thing they did was they looked up all the days that it rained, and then they checked, so given that it rained, how many of those days was there a forecast for rain? And so this is the probability of a forecast given that it rained. That makes sense? And this one right here is, well, what is this? Well, it turns out this is the probability of a forecast for rain on the days that it didn't rain. So the complement to A, right? The probability of B given the complement to A. That's what this is, right? So in other words, it didn't rain on the days that it didn't rain, and they checked that there was a 5% probability that there had been a forecast, so they were wrong a little bit there. So to analyze this a little bit further, what we're going to do is we're going to make a little decision tree, okay? Probabilities are really easier seen, or outcomes, possible future outcomes are easier seen when you make a decision tree. So let's say there's only two things that can happen here in terms of event A. It either rains, which we call A, right, which is A, or no rain, which is the complement to A, right? And then there are, on the days it rains, there was a forecast for rain, or there was not a forecast. So given that it rained, so this is a given that it rained, the probability of a forecast, that's this guy, and this is a given that it rained, the probability that there was no forecast. So the complement of B given that it rained. Okay? Now here what would we have? We'd have two probabilities here. And they're both given that there's no rain. What is the probability that there was a forecast? And so this is a forecast for rain given that it didn't rain. And this is there was no forecast for rain, so the probability there was not a forecast when it did not rain. So this was no forecast. Can you see where that comes from? They're all divided out just by whether or not it rained. Well, what are we looking for? Now let's stop and just think for a minute. Which of these is going to help us? Okay, he says, look, there's a forecast for rain. I think it's going to rain. We need to say, okay, well, what is the probability of rain given? Here it is. We want the probability of rain given a forecast for rain. So how would that be? That would be the probability of A given B. Well, we don't have that anywhere here. We don't have that information. That's not here, that's not there, that's not here. How are we going to find the probability of A given B when we don't have any of that information? Okay, here's how. It's something called Bayes' theorem. And here we go. The probability of A given B, this is just good to know. You don't have to have it memorized, but you need to understand it and be able to use it. So here we go. It's going to be equal to the probability of B given A times the probability of A over the probability of B. So now all we need to do is look and plug these numbers in. So the probability of B given A, well, that was 90%, right? So the probability of A given B is equal to, we can substitute here 90%, so we'll call that 0.9, right? And then times the probability of A, that was 3%, so 0.03 over the probability of B. Ooh. Okay, wait a minute, there's no B. Aha! You think I didn't know that. I was teasing. Of course I knew that. Uh-oh. There we go. Of course I knew that there was no B. I'm getting ready to show you how you find B now. So let's think about what B would be. B would be the probability of B given that it rained, and add to it the probability of B given that it didn't rain. So let's write that out. So we would say the probability of B, right, is going to be equal to the probability of rain times the probability of B given A, right, plus the probability of no rain times the probability of B given no rain. We're not looking for the not probabilities. We're looking for these probabilities times the probabilities that they actually happen. And this is going to give us, our total probability. This, we have to remember, they're weighted. You can't just take this probability and add it to that probability. What if this is 90%? That's 90%. You can't have a probability of 180%. So you always take the forecast, right, the B given A, times whether or not it rained, and that helps weight it, okay? And we take this one times that it did not rain, right? This one times that it did not rain, and then that helps properly weight it. We add those together, we'll have the probability of rain, of a forecast overall, so the probability of a forecast when it rains, plus the probability of a forecast when it doesn't rain, if you add those together. Does that make sense now? All right, so here we go. What is the probability that it rains? So that would be 0.03. That's the probability here, times the probability of B given A is 0.9, right? And we're going to add to it, what is the probability that it didn't rain? Well, if this was 3%, right, then the probability that it didn't rain is 0.97 times the probability that, let's see, we want this one, that there was a forecast and it didn't rain. So where are we going to get this information from? Well, okay, remember that we had some information there. It said, when it didn't rain, then 5% of the time it called for rain. So that was the probability of B given no rain. So we have this information here, which was 5%, right? So it's going to be times 0.05. Okay? So now we just add those together, right? We add all that together. So let me get my calculator here. Hold on just a second. So again, we have the probability of rain times the probability of a forecast that it was going to rain, right? And we add to it the probability that it didn't rain times the probability there was a forecast that it was going to rain, but it didn't. Okay? So when you plug all of that into the calculator, we get a number 0.0755. And you can see that I'd already done this calculation. Okay, and I bring it down here. So this might stun you a little bit. I know it's kind of surprising, but this answer right here is what? That's the probability that it's actually going to rain given there was a forecast for it in July. And that probability was 35, approximately 0.8%. Wow, less than 50%. Just because it called for rain doesn't mean it was going to rain. In fact, less than half the time did it actually rain. It really didn't rain very often. Do you see how we use this Bayes' theorem to find something that is actually quite shocking? Okay, we know that if it rained, yes, it was called for rain pretty accurately, and when it didn't rain, it only rarely called for rain wrong. But just because there's a forecast doesn't mean it's going to rain. In fact, only less than 36% of the time does it actually rain when it calls for rain. That, I think, right there is a shocking, shocking number. And I don't think a lot of people know how to calculate that. Now you do. Okay? I'm going to pause for a minute. We come back. We're going to do one more quick example. I'll go a lot quicker on this one, and then we will get into doing some exercises. Okay, so I'm sorry about that. My phone went off, right? I had to go back and kind of start over again here. So I hope I didn't cut that off too dramatically there, but here we go. This is going to be a story about Mr. T's dog. Poor Mr. T's dog. Doesn't he look sad? So that's my dog, we'll just say. And there's a condition called mange. It's kind of not a good condition for dogs to have. So we're going to say that 1.5% of all dogs have this condition. Okay? Now, let's get some other facts. Okay? When dogs don't have mange, 3% of them have missing fur. And when dogs do have mange, 91% have missing fur. Okay, so those are the basic facts. So the story goes like this. My dog, I see some patches of missing fur, and I'm nervous. I think, oh no, that's a sign of mange. And I go to the vet, and I say, Doc, I'm worried about this. And the vet says, well, let's give you these facts, okay? Yes, when your dog is missing fur, 1.5% of them, first of all, 1.5% of all dogs have some form of mange, right? And if they have mange, 91% of them do have missing fur. And if they don't have mange, only 3% have missing fur. So he says to me, do we think your dog has mange? Well, your vet really knows the answer to this question, right? Let's pretend for a minute and we'll calculate this out. But let's pretend that whatever reason the treatment is either really expensive and or very damaging to the dog if it turns out they don't have mange. So now we really don't want to give them treatment unless we're pretty sure they have mange, okay? So now the question is, how sure are we that this dog has mange? Okay, given this information, how sure are we? Now this is a lot like the problem you just did. And here's what I want you to do. I don't want you to skip forward and find my answer. I'm going to show you my answer. But I'm challenging you so that you can get good at this. I'm challenging you to go back in the video. See how I worked through the last problem. See if you can kind of go through it a little bit. Then come forward to the video to this point and you can play again. I'm going to pause it here. When I come back, I'll have all my calculations worked out for you, and I will tell you exactly, how I did it and whether or not this dog should get treatment for mange. But before I do that, I want you to go back on your own and work it through and see what number you can come up with. And even possibly take your paper, put it aside, and do the same kinds of things in the same kinds of way. Use Bayes' theorem. That would be very good to help you figure out whether or not we should expect that this dog has mange, given that my dog is missing fur. So really, that's what I want you to do. Okay? Pause and come back in a moment. Okay, so I guess then you're ready to go here. Hopefully you have your answer and you could check it against mine. So here we go. The idea that they have mange, I'm going to call that event A. And the idea that the dog is missing fur, we're going to say it's event B. Therefore, we know my dog is missing fur. We want to know what's the probability that they also have mange. So we're trying to find out, given that the dog has fur, what's the probability that they have mange? We're looking for probability of A given B. So these facts were given to us. So the first fact is that 1.5% of all dogs have mange. So the probability that he has mange is at least 1.5%. That's just the probability of mange. It's not a conditional probability, but it's a probability. The next thing, given they don't have mange, 3% have missing fur. So given they do not have mange, so the complement to that, then only 3% are missing fur, okay? And given that they have mange, so the given is that they have mange, then the probability they're missing fur is 91%, okay? So those were the facts that were given to us. I put them in here like this. I made my decision tree, okay? So my decision tree looks kind of like this. Now, whenever you have a decision tree and you split things out, or an outcome tree, or whatever you want to call them, the two outcomes, when you split it two ways, they have to add up to 100%. And if you split it more than two ways, they still have to add up to 100%. So either they have mange or they don't have mange. Well, we know that of all dogs, 1.5% have mange, right? And then over here, dogs, there's 98.5% of all dogs that don't have mange. So see, we're just taking all dogs, that's where this starts, all dogs, and we're splitting them. 1.5% have mange, 98.5% do not have mange. Then let's look inside at the ones that do have mange. Given that they have mange, then 91% are missing fur, and given that they have mange, then 9% are not missing any fur. Okay? Over here, given that they don't have mange, then 3% are still missing fur, and if they don't have mange, then the other 97% of those, that's of those that don't have mange, right? The other 97% have no missing fur. So again, here we are, we're taking the mange and we're splitting them two ways, and these have to add up not to 1.5%, but to 100%, because they represent 100% of that 1.5%. And this has to add up to 100% because they represent 100% of that 98.5%. So these are all of them split two ways, and 3% over here and 97% over here. The next thing is I knew I wanted to find the probability of mange given that there is no hair, or that there's missing hair. So for that I use Bayes' theorem. So the Bayes' theorem tells me I have to find the probability of A given B. I use this formula, the probability of A times the probability of B given A divided by the probability of B. So the probability of A I had here, that was 1.5%, put in as my calculator 0.015 times the probability of B given A, so the probability that they're missing fur given that they have mange is 0.91, divided by the probability of B. I haven't done that part yet. We're going to get to that. So how do we find the probability of B? Well, we take all of the probability that they're missing fur here, given that they have mange, and all of the probability that they're missing fur here, given that they don't have mange, and we add those together. And we just remember that this is 3% not of all dogs, but 3% only of these dogs. And this is not 91% of all dogs, it's 91% only of these dogs. So that's why these get multiplied together. So we're going to go 91%, right, 0.91 times, so 0.91 of the 1.5, so times 0.015, plus, and this one, 3%, so that's 0.03 times the 98.5, so 0.985. Okay, so we're going to add all of that together, and that'll be our probability of B. So let's do that here on the calculator. So we're going to go, so it is 0.91 times 0.015 plus, and we've got what? 0.03 times 98.5, and oops, not 98.5, 0.985, right, 0.985, and we hit enter, and there's our number, 0.432. So now we can put that down here, 0.432. So this is just the probability that a dog is missing fur. The probability of B is that 4% of all dogs are missing fur. So now we got to figure out whether or not the cause is mange, and to do that, given that the dog is missing fur, we're going to use Bayes' theorem here. So let's put it in. On top we go 0.015 times 0.91 over 0.0432. And we hit enter, and there is our answer. What's the probability this dog had mange? 31.6% approximately. 31.6%. So even though Mr. T's dog is missing some fur, that could be because the resident cat chased him down and gave him a scratch. Could be something else is wearing off his fur. Maybe he has fleas or something else. But it is not likely, okay, less than half the time is it going to be because he has mange. Okay, so the vet would probably recommend to me, the vet's probably going to say, well, there is a decent chance, you know, about a third of the dogs I see, a little less than a third of the dogs I see that are missing fur have mange. A little less than a third, but I don't know that we would want to go ahead and just treat your dog for mange. We better look for some other causes. And that is how these problems are done. I hope you got the right answer. If not, I hope at least walking through it a second time, maybe it made a little more sense to you. You know, I like talking it through a second time after you've seen it the first time. And if you're still confused by this, then you might want to get with me because you're going to need to use this in a bit, I think. Thanks.